Okay, well, we're going to go ahead and get started. Again, for those of you who have just joined us, you are attending the Brain Big Thinker web series, The Knowledge Web. Everything's connected. All you have to do is see the links. Today, I'm very excited to bring to everyone best-selling author and famous historian James Burke. James, I'm going to go ahead and pass the floor over to you. We have a lot of chat. People want to say hello to you and say that they're very excited about the event. And with that, I'm going to go ahead and let you go ahead and get started.
Thank you very much, Shelley. Hello, everybody. Good morning, good afternoon, good evening, or good night, depending on where and when you are. For me, it's 4 in the afternoon here in London. Now, this first picture on the screen here is something you'll be seeing throughout this 1 hour of testing, because it's an object that always reminds me of the profound effect of technology on change. Obviously, you know what it is. It's an early Paleolithic stone axe. And if anything triggered the world we live in today, it's probably that. So as some of you may know, I've wasted my life teaching and producing books and articles and TV programs about the history of change and history of science and technology and their social effects in the past, and I suppose to some extent their likely effect on the future. And today what I'd like to do is make a few remarks about, of course, the brain, but also about the future of the future. That is to say, about the basic purpose of the work that I do, which is to try to interest the general public, my TV audience, the readers of the books and the articles I write, in how technology may be affecting the way we think about the future. And after all, that's kind of the fundamental driver of everybody's life. And in particular, how technology like the brain will aid in changing that way that we look at the future and how we deal with it. And I'm concerned about the future because, as the great American sportsman Yogi Berra once said very perspicaciously, the future isn't what it used to be. Now, I spend most of my time on the subject of the future, as you may know, looking at the past. This is because there is nowhere else to look. The future hasn't happened yet, and if you get my drift, never will. And anyway, like all historians and navigators, I kind of believe you only know where you're going if you know where you've been, except, of course, for Columbus, about whom a little bit more later. So before I kick off, in order that you get into proper perspective what I'd like to say about this issue, from the point of view of, I guess, what I am, a journalist and historian, let me remind you of something the late, great Mark Twain once said. He said, talking about people like me and my professional colleagues, he said, in the real world, the right thing never happens in the right place at the right time. It is the task of journalists and historians to rectify this error. So, the business of prediction, never an easy matter. I mean, take, for example, the average medieval man in the street, who would, of course, have fallen off his bar stool laughing at the idea, the suggestion, that cities of the distant future, our world, in those cities, every individual would one day have the means to travel where they chose, when they chose. And he would have found that idea laughable, because clearly in such a situation those future cities would, in no time at all, have come inevitably to a total standstill when every street was 50 feet deep in horse manure. The problem being, of course, the local box you're stuck in. And science and technology are no exceptions to the box. I mean, if contemporary astronomical thought says that the universe is made of omelets, then as an astronomer you build instruments to find traces of intergalactic egg. And if you don't find any, no problem, instrument failure. That whole matter of paradigm constraint, I suppose, was once cogently addressed by this guy, the great modern philosopher Ludwig Wittgenstein. He's the guy who ruined every manager's life when he once said, if anything can be said at all, it can be said clearly. Anyway, somebody apparently went up to Wittgenstein and remarked what a bunch of morons we Europeans must have been, back 800 years ago, before Copernicus told us how the solar system worked, to have looked up in the sky and to have thought that what we were seeing up there was the sun going around the Earth, when in fact, as any idiot knows, the Earth goes around the sun, and it doesn't take the brain of an Einstein to get that. To which the great Wittgenstein is said to have replied, yeah, but, he said, I wonder what it would have looked like up there if the sun had been going around the Earth. Point being, of course, it would have looked exactly the same. What he was saying, I think, was that in any circumstance you see what your information of the time tells you you're seeing. Now, given that, the trouble with second-guessing change in the modern world seems primarily to be that a continuing high rate of innovation is now changing what you think you're seeing faster than most institutions and individuals can keep up with. By the time most people understand how some new gizmo works, it's already obsolete. So I think one finds that the reaction of the typical consumer to the avalanche of novelty we live with now reminds one of the story of the depressive who gets a couple of days off from the clinic where he's being treated, goes to the beach to get himself a tan. A couple of days later, his psychiatrist back in the hospital gets a postcard from this holidaying depressive. The message on the card reads, I think, much like the general public's reaction to today's accelerating rates of change, because the message on the card reads, having a wonderful time. Why? Now, I would argue that the challenge posed by innovation basically stems from the way knowledge has been regarded over the last few hundred years, and I think this view can without a doubt be traced directly back to Columbus. Here he is. Not for discovering America, but for the fact that back then the definitive last word authority on all knowledge is Aristotle, and whose definitive last word includes, of course, a map of the world on which, you will note, America does not appear. So in 1492, what the hell is it doing there? And much worse is not. Throughout the century after Columbus, flooding into Europe from this supposedly non-existent place, and then other newly discovered places around the globe, come new plants and animals and minerals and people that nobody's ever seen before, and they're not in Aristotle's definitive lists either. So, in the intellectual panic that follows a discovery, like, if Aristotle is wrong, there goes the epistemological neighborhood, a French military engineer, the guy I blame for everything, named René Descartes, comes up with a solution, a technique that allows trustworthy data to be generated, but faster and more complex than people like my general audience can keep up with. A technique that also locks down how we innovate and how we think about knowledge and innovation from then on, because what Descartes does, of course, is to work out how to generate the kind of data that won't let you down, like Aristotle's did, with a set of rules for thinking that everybody conforms to. The modern world is built on Descartes' rules. What he says is, apply methodical doubt. If a guy tells you something is definite, think of it as probable. If he says it's probable, consider it possible. And if he says it's possible, forget it. And he adds, be reductionist, that is, reduce every problem down to its elementally small, indivisible parts, component parts. That way you'll know how it fits together, how it works, and if it breaks, what to do about it. Now, back then, we Europeans approached this new way of thinking with all the abandon of an alcoholic in a brewery. The result, methodical doubt and reductionism, kick off modern scientific method and turn the process of innovation into a noodler's paradise. Pretty soon, the reductionist mission statement becomes the one that has driven discovery and innovation and business and expertise of any kind ever since. The maxim, learn more and more about less and less. Like a pal of mine at Oxford who got his doctorate in an obscure 17th century poet's use of the comma. He is now the head of department at a major university because he did what reductionism requires you to do to get ahead. Make your specialist niche so small there's only room in there for you. And then explain yourself only in your own idiosyncratic gobbledygook. In this way, you are incomprehensible and therefore irreplaceable. This is the reductionist approach to the matter of knowledge and, more important, who gets it, and it's triggered accelerating innovation and the explosion of data ever since Descartes. Because along the way, as reductionism has taken hold, the effect, of course, has been to fragment and multiply the disciplines into scientific and technological niche studies, which then, of course, over time become disciplines in their own right, generating their own niche studies. Now, this scientific drilling down into the core of an area of expertise and the consequent emergence of stuff so specialized that few outside the field can understand it, as I am, for example, reminded every time I talk to anybody about the vacuum expectation value of the Higgs field, is also, of course, the reason why we in the industrialized nations are the healthiest, wealthiest, richest people in history. Because the reductionist process has triggered spectacular advance in each generation. Since Descartes, a small number of noodlers has achieved what the previous generation might have described as miraculous. my laptop could have easily landed Apollo on the moon and done my tax returns at the same time. However, there is another intriguing aspect to this kind of predictive focused behavior. That is the way in which a lifetime of silo thinking, which modern research often requires of its acolytes, head down at their workbenches, can sometimes make it difficult for the individual or even corporations or even governments to predict how some esoteric piece of software or whatever innovation it is they're working on may end up having unexpected ripple effects when it gets out into the so-called real world, because thanks to the highly connected nature of innovation and change, those ripple effects often occur in areas apparently totally unrelated to the original work. Take the case of this medieval example now. As I'm sure you know, this is a little bit of the Bayeux Tapestry, woven in about 1077 to commemorate the Battle of Hastings in 1066, when the French beat us Anglo-Saxon English and invaded England because, as you can see, they fought on horseback and won, and we fought on foot and lost. Well, they were on horseback because they were using this. If I can highlight it there, see that? They were using this stirrup. This was a new gizmo recently arrived in Europe from probably Afghanistan, where it had been used as a single step up to put your foot in when you were climbing up to load a camel. Now, the French realized that if you put one of these steps on either side of a horse and stuck your feet in both of them, then you'd stay anchored on the horse when you hit the enemy with your lance and the full weight of the horse, and you wouldn't get pushed off the back. Shock troop, it was called. So the French cavalry creamed us Anglo-Saxon foot soldiers. All right, better military technology wins battles, nothing new in that. But then came the ripple effect, because when the French took over England, they also took over the language. And that's why hundreds of millions of us around the world, all of us in this seminar for a start, speak the way we do and not the way we would be speaking if the French had not used that stirrup and won the battle, and therefore if the English language had not become half French, which of course it is. We would still be talking unadulterated Anglo-Saxon, like this. The unexpected worldwide ripple effect of one little camel-loading gizmo. And that happens all the time, that ripple effect. The typewriter took women out of the kitchen and into the office and boosted the divorce rate. Asbestos protected you from fire and was carcinogenic. The first refrigerators kept food fresh and punched a hole in the ozone layer, and I'm sure you can think of dozens of examples. Second-guessing ripple effects can be difficult because the future you're thinking about is almost never a simple linear extension of your local present, the box you're in at the time. Let me illustrate from my own work how non-linear the path of change can be, with a not too serious sequence of events, connections, if you like, from the history of technology that ends with a modern innovation which I assure you, every one of you listening to me now, is intimately involved. So, in one sense, you ought to be able to predict where I'm going with the story before I get to the end of the story. Let me start. It was a dark and stormy night in 1707 off the southwestern coast of England, and Admiral Sir Cloudesley Shovel is bringing the great British fleet back to England. Now, he isn't quite sure where he is, so he decides to turn right, and the whole fleet obligingly turns right, hits northern France and sinks, and the entire British fleet is lost and everybody aboard. Unsurprisingly, this stimulates the British Parliament, to offer a rather large prize for anybody who can come up with better navigation techniques. So a Yorkshire clockmaker called Huntsman goes looking for better steel for clock springs. Here he is. No, it's not. Since knowing where you're going, east or west, involves knowing the time back at base. So you can work out to the second how much earlier or later the star or the sun or some heavenly body came up above the horizon, and having worked that out and knowing what time it is back home, you can work out where you are. It's the problem of longitude. Now, at the time, this matters tremendously because we Brits are busy sailing across the Atlantic to exploit the Americans. Well, the steel which Huntsman invents is terrific for clock springs, and also, it turns out, for cutting other metal. So an iron maker named Wilkinson uses it to carve out thin-walled cannon barrels which, in spite of the fact that we are at war with both of them at the time, he sells to the Americans and the French. Nothing changes. A little later on, Napoleon uses these new British cannon barrels to develop mobile horse artillery and win all his battles, except the last, and start the empire. And in 1810, he sets up a prize to encourage French inventors, and a champagne bottler called Nicolas Appert boils up some food in a sealed champagne bottle, thus inventing a way to kill the germs that nobody knows exists, and preserve the food. It works. 10 years later, an English company is doing it in cans this time because they bought Appert's patent. In the Paris patent office that day, they also come across and buy another patent that nobody seems to want, which is for a new continuous process wallpaper making technique, which eventually allows these guys to return to London, where advances in ceramic pipe technology are permitting vast new sewage works to be built, and to modify their continuous process wallpaper making technique so as to produce the world's first toilet roll. You see what I mean, I hope, about innovation being surprising. I mean, how could anybody have predicted the toilet roll from even the most frightening of navigational problems? But what is happening here is, I think, the reason all my programs and books look the way they do, that is the fundamental connective process involved in the way change, innovation happens, and the main reason it has so far been hard to predict. It's the way in which innovation most often happens when things or people or ideas come together in ways that reductionism says they're not supposed to. Because when that occurs, the rules of math change, and suddenly 1 + 1 = 3. That is, the result of the process is more than the sum of the parts. And almost always, because of that silo thinking I mentioned, encouraged by specialist reductionism, almost always unexpectedly so. For example, late 19th century German engineer Wilhelm Maybach puts together the antiseptic spray being used in hospital operating theatres so surgeons know about them, and kerosene being used in oil lamps so lighting engineers know about them, and comes up with the carburetor for automobile people who know nothing about either antiseptics or illumination. Another one. William Perkin, 19th century chemist, is messing around with coal tar because coal tar is a free byproduct of gaslight manufacture. And what Perkin is trying to do is to make artificial quinine, I believe you say, to save our troops who are dropping like flies out in the steamier parts of the colonies where there's plenty of natural quinine, but which belongs to the Dutch, who are typically charging an arm and a leg. Well, after some months of effort, Perkin comes up with some gunk. One thing it is not is artificial quinine. So he chucks it down the sink, sees what it does to the water, and becomes a millionaire almost overnight because he has accidentally invented the world's first artificial aniline dye. Not long thereafter, a German medical researcher accidentally spills some of this new dye into a petri dish and sees that it preferentially stains and kills one bacillus. Bingo. Chemotherapy from gaslight. And that kind of 1 + 1 = 3 thing has been happening with increasing frequency ever since Descartes, with the result that today ever-increasing rates of ever-proliferating innovation generated by ever more specialist disciplines are now bringing the rest of the world and the way it affects our lives closer every time we draw breath. Thanks to which, to judge by my inbox, my audience finds itself like that holidaying depressive I mentioned at the beginning, enjoying the good life which innovation has brought, but given what we perceive from inside our box to be the deleterious long-term effects of globalization in an outsourcing, cutthroat competition, carbon rationing, flat world, wondering how long the party will last. My response, of course, would be that all is not entirely lost. Thanks to a killer app in plentiful supply and only waiting for release, a killer app which every one of us has, called TheBrain. Let me say a couple of words on this subject because it might relate to how we, especially in the industrialized nations, go on enjoying the privileged life, and also why it might turn out to be a little easier than we had previously thought for us to get the jump on unexpected or unwelcome innovations. As you know, I'm sure every healthy brain on the planet has about 100 billion neurons, each carrying up to 50,000 dendrites, each of which is potentially in contact with up to, 250,000 other dendrites. So it looks as if the potential number of ways a signal can go through all that is greater than the number of atoms in the known universe. And everybody has a brain. So maybe there are other things it could do, given an assist, as well as go down the ever more narrow reductionist path. Maybe this guy was right when he said, we are all born with magnificent brains, which formal education then slowly destroys. I think he might have been referring to the linear reductionist mode of thinking that you're taught in school. Because the most innovative solutions often appear to come, don't they, when the brain is kind of freed from the nuts and bolts, not concentrating on a problem. The last thing much creative thinking, much innovative thinking appears to be is straight line, reductionist, neatly taxonomized, thanks to the connective nature of the way the brain works. This may explain, for instance, why you are successfully solving the extraordinarily difficult problem of understanding me now. What I mean is, if you think about this speak-listen event going on between you and me, there is no time, is there, for you to hear what I've just said, go into some kind of lexicon in your head, and then go through the sounds in that lexicon until you identify the one you just heard, stick it together with the last sound or last set of sounds you heard, see that the entire sound string to this point makes sense, and think, okay, and go back out and start listening for the next sound, and then doing that as I go on uttering sounds. Now, even if that's all you were doing, and if all you were accessing and there was a lexicon the size of the average high school graduate's vocabulary, 12,500 words, think about that. There are 414,812 in the language, so the average high school graduate's vocabulary of 12,500 words, then at 1 millisecond per act of neural retrieval, it would be taking you 12.5 seconds to identify each word, and you're not doing that, are you? I hope. So what are you doing? You're running simultaneous connective scenarios ahead of me, using the syntax and the grammar and the content, possibly even the intonation of what I've said so far, to power up all the probable sounds I will make next, and then powering down all the wrong ones as I come on through while powering up the next set of probable sounds, and going on doing that in real time as long as I make sounds, which of course means that you are all giving this seminar before I am, or any other seminar I might have done, or anything anybody else, including Shelley, might have said at this event. One wonders why you've logged in. Now, by the way, the ability to put connective scenarios together, I hope you'll be happy to know, seems also to be why brains like jokes. The punchline brings together two concepts that are new to you, and since that's what the brain appears to be for, the connective structure is for, you laugh in pleasure at having your connections enriched. Let me try it on you. Every brain logged in today contains inside it the concept bird and the concept fruit. And like everything else in the brain, they are linked. Your link may be bird tree fruit, bird season fruit, bird color fruit, bird eat fruit. I don't know. See if I can put a new link in there, and if I can, you will laugh in pleasure at connectivity enhancement. So, bird and fruit. A drunk goes up to his host at a party and says, with that, clarity of diction reserved for the totally zonked, "Excuse me." And the host senses something wrong, and he turns around, and there's the drunk, wild-eyed and swaying, and the host thinks, there's a problem here. So he says, "What's the problem?" And the drunk says, "Could you answer a question?" And the host says, "Yes, what's the question?" And the drunk says, "Do lemons whistle?" And the host, they don't whistle. Why do you ask? And the drunk staggers back and smacks his forehead in chagrin and says, "Oh my God, in that case, I have just squeezed your canary into my gin and tonic." You see how innovative thinking may act, therefore, in some ways just like a good joke. But I make a serious point. The brain seems naturally configured to work in the 1 + 1 = 3 mode, to have innovative ideas, because its prime job is security and survival, to create for itself a networked virtual model of the world, and then use that model to match against events, above all to spot any suspicious anomalies out there that might indicate change and therefore a threat, and then inform you. And as Claude Shannon, the inventor of information theory and my hero, once said, information causes change. If it doesn't, it's not information. I suppose an example might be there is no information in the statement, "Now you are sitting in a seat." There is information in the phrase, "Your keyboard contains traces of a communicable and deadly virus." The most important cognitive thing about a brain appears, therefore, to be that all it needs is opportunity. That when you're talking about the present globalization challenge, can we survive in an ever more interdependent world of outsourcing and job loss and level playing fields and competition for scarce talent from the so-called threat economies and all that stuff? It is worth remembering that, for example, in the United States alone, at last count, that is yesterday, there were 303,083,444 brains, the vast majority of them unused, waiting for that opportunity I mentioned just now, the opportunity to think innovatively. An opportunity which up to now, of course, they haven't had, because up to now there was never enough technology to let more than a few people in on the act. History's so-called geniuses, thanks to which, of course, in one sense, the modern world is the product of less than 1% of the brains available at any time in history. That is, a tiny number of brains with the means to accent the relevant materials in the small, slow database equivalents of more than 100 years ago. That is, essentially, paper and parchment libraries. Now, I wanted to make that earlier point about the brain's functional readiness, because when you get down to how we might manage to innovate fast enough and consistently enough to stay ahead of the game in this new global jungle, given everybody's brain's natural ability to think innovatively, if we had the technology to help them either get into the game or out of the silo, we have a long way to go before we run out of cerebral talent. And that's counting brains only one at a time, never mind, as they say, when two or three are collaboratively gathered together, as you can easily be, for example, when you're using the brain. That is the brain, as in brain.com. However, although in that sense there's no shortage of potential talent, and even though the cost of information technology to make use of that talent is falling like a stone, the present problem seems to be persuading the talent to get involved in the first place. I mean, a recent survey shows that something is happening to cause young people to lose interest in science and technology careers as early perhaps as the first years of secondary education. So the call from that recent summit in Washington for a new educational and training culture that would encourage innovative thinking would seem to indicate that secondary education would be a good place to start. And since it takes, 30 years from preschool to get a fully qualified professional on the job, then maybe the time to start is now. As some of you may know, I take a connective approach to the history of knowledge. So my small contribution to this endeavor is something connective I've been working on in my spare time for the last few years, because, like many people, I believe there are only three things that matter when you're in a rapidly globalizing economic, cultural, and political environment, and those three things are education, education, and education. My plan would be, when this connective thing I'm working on launches on, I hope, next year, it'll be free for schools or anybody to use. It'll be aimed at making the data that users deal with more accessible, more relevant, by giving context to the data, showing the users that no matter what Descartes said, no data exists in boring or apparently irrelevant isolation. And maybe because of the way this kind of tool works, in a more general social context, how it might facilitate the involvement in any problem-solving exercise, business or social, of people not necessarily from the same silo, or even from the same discipline, or even from any discipline at all, what used to be called unqualified people, like members of a community, or, if you're a business person, customers. Because throughout history, the most innovating events always seem to come at the edge of disciplines, where they bump into other disciplines, or else from an individual's area of informal expertise, sometimes on the penumbra, the periphery, if you like, of their core competence, a talent which has often been described dismissively as experience. And last but not least, I hope this kind of tool might show educators that the value of working in this relational way, similar to the way in which the brain works, means also, therefore, learning to think connectively, that is, innovatively, from the start. Now, what I want to show you is still work in progress. We're working as volunteers. These things take time. People aren't free to help as much as they'd like. So what I can show you is kind of the plumbing rather than the facade. But I'm sure you know as much as I do about how difficult it is to go from plumbing to finished building. Anyway, what I'm talking about is this knowledge web is aimed at primarily high school users. or intelligent people anywhere from 10 to 80. And it's basically a web of about 2,800 nodes. And nodes are people and events and ideas and innovations taken from history and split about equally between the arts and the sciences, with each node connected to other nodes, the way we all are connected, through the people we work with, the people we love, the people we hate, the people we influence, the people we compete with, the accidental things that happen to us, and so on. So these 2,800 entities appear in this knowledge web as nodes on a network web, interconnected a total of about, at the moment, about 30,000 ways. And the name of the game is to make journeys across this web, making notes as you go along, using various tools to access and record and search anywhere on the internet if you temporarily need it, track your progress, build other webs, and do all those things you might want to do, and which, of course, as the purpose of which I'm using TheBrain. If you're interested in our Q&A afterwards, I'll tell you how it all started, but I won't bother you with that right now. But at the very beginning, I started by getting large sheets of paper and making connections. And when these sheets of paper covered several rooms, and my wife and others began to be concerned for my sanity, I started looking for technology to help. This is some years ago, before technology was generally available. One of the things I tried was mind mapping. There are many kinds, and the ones I looked at in the past had several problems associated with some of the things I've been telling you now. I mean, above all, many of them are hierarchical, knowledge trees, which is fine until you want to not use that approach, a non-reductionist approach. Most of them are not scalable. I couldn't find one that was actually dynamic the way the brain is. They're not large enough, and of course what I want to do with my knowledge web is turn it into something, which ends up being, the monster that at New York. I mean, I see no reason why the knowledge web should not contain all human knowledge. So, I'm not modest in my aims. It's not easy, as I said, dynamically to move stuff around and recenter with the ordinary standard mind map. So, where are we? Let me show you something before we get going. This, the knowledge map itself, of course, is based on the nodes, and the nodes are essentially biographies or written descriptions. And here's an example, Newton, Vital Statistics, Life and Times. People he knew, hyperlinks so that you can jump straight to whatever else or whoever else you want. And then at the end of it all, bells and whistles that younger people need these days. Well, not just younger people. Animation, we hope soon 3D, so that you could actually, go inside the environment in which Newton worked and kind of walk around and take a look and so on. So that's the core element. This was an idea. These are nodes, and these are the links, and as you can hear, kind of inside a cosmos or universe of links, there would be drop-down things like, did you want to search by name, by some kind of relational link, by country. There's over here, you could switch around countries. You could follow your trail down here. Really bad description here. Look at this. Where you've been and where you could go. A timeline, more detail with your thing. The list of the last few people you've been to, and so on. And most important of all, your storyline as you went through this journey. Over here would be the storyline made up of each time you clicked on one of these things, there would be a one-liner that would come up. And the one-liner would go over here, and then you'd list, have a list of one-liners which would remind you of your journey, and then down here there'd be a semi-intelligent, I use that word as advisedly, semi-intelligent avatar to help you. So what I was doing there was showing you one of the ways of getting in, the interface. The interface is turning out, obviously, to be the most complex and most time-consuming and most potentially expensive, if we were in the world of money, to do. So if any of you listening are, emeritus with lots of time on your hands and brilliant designers, boy, do we need help for this, because this is the only thing, not this, but the interface for the specifications for which I have written in great detail. It's the only thing standing between us and a full launch of a beta, which we hope we'll be able to do fairly soon. Let me try the next one and see. What one of us has come up with is this, and I think I quite like it. It's one way of doing it. Here's your cosmos of knowledge, as I mentioned, and if I can make it spin, which I can't because I'm too stupid. Oh, no, here it is. Right, here we go. So you get this thing, and here you are as a young person, and you think, the cosmos of knowledge. I'll fly in with my little space, spacecraft into this world of knowledge, and I will land somewhere, and you say, well, I'll tell you what, I'm interested in, I'm interested in Bohr, Niels Bohr. And you land on Niels Bohr, and you see, here he is, and you see he's linked to some other people, and there's some notes on the kind of relationship between Niels Bohr and bottom left, for example, Rutherford, or bottom left, Heisenberg. And this is a set of transparent nested spheres with the ancient past at the center and the modern world on the outside skin. So we go through the 20th century into the 18th, 19th, 18th, 17th, blah, blah, blah. Now what you're looking at is a test run by our brilliant engineer, Jim Zorn, who designed this, and it's only a few hundred. As you know, there will be at least 2,800, if not more. So it's going to be interesting to watch how Jim can develop this into something which remains coherent, but we live in hope. Okay, and now we get to the guts of it. Here, hooray, hooray, at last, is the brain. Now, I like Brain 3 because it's just a personal preference. One of the things I like about Brain 3 is it makes it easy for me to remain, maverick. You'll gather from the first half of my presentation, P.S., there's that length to go again in case you want to go to the toilet or actually just switch off. But I'm keen on non-hierarchical. I'm not interested in trees because that's not how life works. I mean, I believe that we are taught, subject materials in subjects at school because ultimately that's easier to grade. In fact, if you look at any aspect of any subject or anybody's life or whatever, I mean, it is not hierarchical. We bump into people, subjects bump into each other. I hope to show you some examples in a minute. So anyway, here is my Web 3, and here's Newton, and the white lines lead out to all his major links on this web, and the little yellow people are some of their major links. I mean, like here's Arbuthnot with some of his links, here's Occam with some of his links. I mean, and it's just general fun. You can jump around if you want to, just play, or you can think about where you want to go. And of course, in the final version on these white lines, there will be little pop-ups telling you why Newton knew or had any relationship with Bayes and so on, or why Bayes was linked in any way to Laplace, and so on and so forth. Anyway, so the name of the game being make it easier for the young people. So what I've tried to do is in the people the outside sphere, if you like, of that one example of a way in, with easy gateways, because you don't want to say this stuff is difficult, you have to have a PhD, because who has a PhD with their 9? So put something easy there that doesn't threaten. So for example, say chewing gum. I mean, chewing gum is not frightening. Wait a minute, I haven't done it correct. Got to put my little signal in. Here we are. Right. Chewing gum. So let's say, we'll try chewing gum. That won't frighten anybody. Let's get in. And immediately you see chewing gum starts you on a journey. I'll take one. Chewing gum is introduced to the United States by the dictator of Mexico called Santa Anna when he's rooming in a boarding house in Staten Island and chewing this stuff, and somebody next to him says, hey, what's that? And he tells him, and the other person, a young American, goes out and becomes a millionaire by starting the first chewing gum factory, or whatever you call it. Now, among the various people that Santa Anna's life included was a man called Robert Owen, who was a libertarian mill owner from England and who wanted to set up a utopian commune in Mexico. And he went to Santa Anna and said, could I do that? And Santa Anna said, no, get lost, I have better things to do. And Owen went off and did it in New Harmony, Indiana. It ultimately, as all of them did, failed, but nonetheless. Okay, now one of Owen's primary contact, and indeed a sort of mentor, was a fellow called Godwin, who was a kind of proto-socialist, and he was linked in the main to other thinkers, including, I'll have to shift this a bit to see him. Where is he? Here we are. Including, of course, the thinker that everybody at the time was connected to in one way or another, Voltaire. Voltaire, apart from being a general genius and being on the run from the cops all the time, and knowing everybody, had the good fortune to shack up with the most beautiful lady called Emily du Châtelet, and lived with her in her chateau, and the two of them did amazing intellectual things, and the brains of Europe beat a path to their door. And one of the things du Châtelet was doing, she's one of the great first early feminists, was writing a book for French women about what Newton meant by his Principia. So there you go, from chewing gum to Newton in, 8 jumps, and none of them very difficult. The other thing I want to do with this technique and using the brain in this way, which you can do, and as you see, it's dynamic, and you can add anything you like to it, and it never stops growing, is to say, take a look at when you take a journey on this web, you see immediately what I was trying to say earlier, that things do not exist in neat, discrete, subject-oriented taxonomies or chunks. You start with something like at school with somebody like Mozart, and you're going to go on to deal with music, aren't you? Well, there are many other things besides music that you get involved in if you use this kind of brain approach. Mozart, short story here, Mozart stole the idea of the marriage of Figaro from I'd argue, fifth-rate French playwright called Caron de Beaumarchais. And the reason Caron de Beaumarchais matters to you Americans is because he was the guy that the king got to launder all the money, and by all the money I mean enough to bankrupt the French state, all the money, ships, guns, uniforms, sailors, soldiers, ammunition, across the Atlantic to you Americans so that you could fight the war against us Brits and win. And of course we would say without Beaumarchais you would not have won. Anyway, because of what he did, Beaumarchais, naturally enough, was a very, very good pal of Thomas Jefferson. So Thomas Jefferson, again, another libertarian fellow, he tried to get, for example, the death penalty taken off the books in the state of Virginia and failed by, I think, 1 vote. Anyway, Jefferson, being that kind of guy, was profoundly affected by all those people he's connected with, but this one here, Cesare Beccaria, a small, elegant magistrate in Milan, who wrote the very first book on prisons. What's a prison for? I mean, you send people to prison in order to bring them back, better people out into society. And if so, what is the point of the death penalty, he said. I mean, why does the state commit murder in order to punish murder, and so on and so forth. And he kicked off that whole argument about penology. And he got much of his attitude towards life from 2 crazy guys from Austria called Gall and Spurzheim. Gall and Spurzheim invented phrenology, known nowadays as head bump reading. At the time, there was a school of thought that inside the head, your brain, which controlled everything, had different organs. You had an organ of greed, an organ of amity, an organ of friendship, an organ of generosity, blah, 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 blah. And if these organs were very well developed, obviously their part of the brain would be bigger, and they would make a bump in the skull above them. So if you ran your hands over somebody's head, you could read their bumps and read their character. Now, this is very valuable when you're trying social reform stuff. You could say, this person has the incipient tendency to be a criminal, so we must do something to reform them, and so on and so forth. It was a tool, sociological tool. And as such, it appealed greatly to this guy down here, a fellow called Follen, who was a German radical, and he got himself into trouble, I can't remember, something violent, and was hauled up before a judge called E.T.A. Hoffmann. Now, the thing about Hoffmann is when he wasn't being a judge, he was being the writer of the first of those books, creepy books where the midnight bell tolls and the ghosts come out of the graves and they come into your house through the window and they suck your blood and then they go back to the grave before dawn. And he was tremendously successful with these tales of Hoffmann and appealed mightily to a writer who went on to do similar kinds of things in English called Edgar Allan Poe, well-known author and drunk. And Poe had a great fan, and I think one of his ideas was used by the composer Rachmaninoff. Rachmaninoff was at a party in Long Island one day at the beginning of the 20th century, and he met another young Russian immigrant who impressed him so much he gave this guy $5,000, which back then was a fortune, thus enabling this young man, Sikorsky, to develop the world's first fully functioning commercial helicopter. So you see Mozart to the helicopter in 15 jumps, not one of them, well, yes, one of them music, but not the rest. Okay, let me get back to where am I? Here we are, back to this. No, not that. Well, never mind, we'll get there. Now, the more general aim of this knowledge web is, of course, ultimately to service the innovation requirements of the next decades, not this web, but this kind of approach to stuff, by encouraging users of all kinds to think and work more cross-discipline. as you can see, using the brain, cross-discipline thinking is something kind of that you can't avoid. To try and make people aware that anything they know is probably meaningfully related to something somebody else knows, and that identifying those relationships may not be difficult given a interconnected process like a knowledge web and the kind of software, the brain, with which to access the data you might need to build knowledge webs of your discipline, of the general field you work in, of the community, of the global, social, political, commercial environment, and so on. My approach for the high school user and the general audience would be probably to embed the subjects and the disciplines that they're interested in or they're studying inside the knowledge web construct so that they can travel alone or in teams across this knowledge web to investigate their discipline's links with other disciplines that are generally not identified in the standard, isolated, reductionist way information is packaged and anyway arranged according to pre-designed taxonomies inside that discipline and no other, that locks that data up in silos accessible only to people who speak that gobbledygook or have that particular expertise. And on a wider level, an assessment of talent in this web traveling exercise might no longer be just a matter of whether or not the user knew some one-size-fits-all answer, I mean the so-called correct answer, and could pass exams, but seeing what kind of pathway the user took across the web, how they put things together, what connective linkages they made when they were attempting a solution to a problem or a new approach to some procedure. From a social perspective, the reason this connective technique seems generally germane right now is, I suppose, because if information technology is doing anything, it's creating a world of such increasing interdependence. I mean, look at the subprime issue, that we need to think more cross-discipline than ever before if we are to be capable of handling very much higher and more interactive rates of change by using knowledge web techniques, software like the brain, to become more aware of impending change ahead of time. I'm getting to prediction, as I said I would, because we live now in a world of such network connectivity that we're also discovering that in many cases the old reductionist way of solving one problem at a time may not be enough or fast enough or relevant enough anymore. And this is true in many businesses where increasingly what used to be separate parts of an enterprise are now having to find ways to access and correlate all their separate information silos when, for instance, they're bringing together more than one product or more than one process within their corporation so as to meet an individual client's demands for customization. On that score, it's not inconceivable, given also where virtual software is going, to imagine a day soon when consumers themselves become involved in that process, when companies provide kind of online websites that might be more like virtual warehouses, housing products and ideas where the data can be correlated and assembled virtually to satisfy each individual customer's idiosyncratic requirements by that customer's electronic agent at any level of demand, from pizzas to politics to postgraduate degrees. And those electronic agents, whose job it would be to carry out those tasks, could themselves turn out to have the greatest social effect since computers, because sooner or later every individual on the planet is likely to have one. Now the logical end of that process, and it gets me to this picture which should not have been sitting here for so long, it might be the end of intermediaries. The people or organizations we always went to in the past for their expertise, because in our culture of scarcity with which we've lived throughout history until now, those intermediaries had the tools to do a specific job, and we didn't. I mean, a classic example of the intermediary at work is representative democracy. I mean, invented in the 18th century, if you think about it, to solve a very specifically 18th century problem: lousy roads and no telecommunications. So what you do is you find a couple of fools with a horse and time to spare, and you send them up the dangerous, bandit-infested roads to the capital to represent the local hayseeds. Now, the roads are so dangerous or so difficult that they're not going to come back the next day and say, have you changed your political minds? So infrequent but regular return journeys are organized. Over time, we come to refer to these horse-owning fools as politicians, and their return journeys elections. We have one coming up quite soon in America, and in England today.